So yes, in the last class, we had started with this lesson, chapter number 3 of your NCRT, that is current electricity. So Zed, I think you were absent in the last class, no? Did you take the recording or something? See, we had discussed it till the relation between the current and the drift velocity. Now see, drift velocity is basically the average velocity with which the electron drift towards the positive terminal because they get attracted. All right, Zed, fine. It's okay. So basic things we have covered, basic formulas we have seen. Let's just quickly revise it. This is drift velocity, which is E capital E tau divided by M. E is electronic charge, E is the electric field, tau is the average relaxation time, M is the mass of the electron. Now there's a relation between electric current and the drift velocity. Just a second. Yes. So there's a relation between drift velocity and current. Now that derivation also comes in your exam, as I have told you in the last class, which is I is equal to NEAVD. Where did we do it? This one. I is equal to NEAVD. And two conclusions we had drawn in the last class. That current looks directly proportional to the area of the cross section, but actually current is independent of the area of cross section. Even if the ends of the two pipe, the wire, basically not a pipe, we are considering a wire. This is a non-uniform wire of non-uniform area of cross section. So even if it is given in this way, A1 and A2 is wider than A1. Current at both the ends is same. I1 is equal to I2. Now drift velocity is the first velocity at the first end, and VD2 is the drift velocity at the second end with area A2. Drift velocity is inversely proportional to area. So if A2 is greater than A1, then VD1 becomes greater than V2. Inverse. Wherever area is narrower, velocity becomes greater. And wherever area is wider, the velocity becomes narrower. So this is the cases about drift velocity. So we had covered drift velocity. Now we have to start with Ohm's law. See, Ohm's law, everything, all the writing portion, I've already written it for you people, so that it saves our time. Now see, Ohm's law is basically you have to have the knowledge of potential, that is voltage. You have to have the knowledge of current. Then a new term is introduced with the help of Ohm's law, that is known as resistance, which we will see in detail in today's class, resistance as well as resistivity. So Ohm's law says that if two conditions remain constant, they do not disturb your wire, pressure and temperature. Pressure and temperature. These two quantities remain constant. Then all of your potential is directly proportional to the current that is flowing. So basically your Ohm's law will show you. If let's say this is a section of a wire, I have drawn it broadly, otherwise this is this much wire only, this thin wire only, just so that we get an idea, or so that we are able to see the structure in detail. That's why I'm drawing it broadly like a cylinder, but it's a thin cylindrical wire only with the help of which current is flowing. All right, so here if we have I current flowing, V is the potential of this wire. Then if temperature and pressure, these two quantities remain same, then all of this potential is directly proportional to the current. This is basically your Ohm's law, this very simple statement. And in exam, you can be asked to draw the graph between V versus I, or to write Ohm's law. So writing the definition of Ohm's law, what was exactly statement of Ohm's law, is not tough. What are the two things that remain constant? That should remain constant: temperature and pressure. And the current flowing through the conductor is directly proportional to the potential difference that is applied across its end. Now, in mathematics or in physics, wherever we have the proportionality sign and we have to remove this sign, then we put an equal to with a constant. That's how we solve. a proportionality sign is always removed with the help of a constant and an equal to. So here also we'll be having a constant that I'll be naming it as R. Now this constant that is obtained with the ratio of potential and current, this is known as the resistance. Resistance is what that we'll see in detail. Resistance, I'll tell you it brief also right now. So here R is what? R is the resistance. This is the potential difference. I is the current, R is the resistance, and this is your Ohm's law. Now see, as you can see, V is directly proportional to R. V is directly proportional to I. Means this forms what? This is a linear equation with the power 1. So if V is directly proportional to I, their graph will be a straight line. If you plot a graph between V versus I, the graph will look like this, a straight line graph. V versus I graph. This is a straight line graph. Now, understanding resistance, I'll tell you what is resistance, and there are other formula of resistance also that we'll discuss. We'll derive actually. Derivation is there in your course. But understand resistance. See, I told you in the last class when we were discussing the current, when the electrons were flowing, basically the current was flowing. Drift velocity, when we were discussing, I'll show you the figure, what we had discussed in the last class. This one. See, electrons are there, positively charged ions are there, walls of conductor is also there. Conductor means the walls of the wire. This wall of the wire is also there. So these structures are present. So when electrons are moving continuously, the whole bunch of electrons which are moving, they are colliding. It means something is opposing their motion. All the electrons were drifting towards the positive terminal because they got attracted towards the positive terminal as we connected the wire with the cell. As we connected the wire with the cell, all the positive part of the cell was attracting all the negative part of the charged particles, that is the electrons. So we saw there was a motion opposition as the electrons were flowing because some obstruction was there to the flow of the charges. That obstruction or that opposition to the flow of charges, that we call as resistance. So resistance is basically, even in normal terms also you say I am resisting to this. That resist word means to stop, not stop exactly, to oppose the action. Similarly, resistance term is also used in case of current electricity to just tell that the motion of electron is opposed, and it can be opposed by the particles present in the wire, or it can be opposed by the electric field. It can be opposed in any manner because of the negative terminal, anything. So that opposition, that is known as resistance. Yeah, so note down Ohm's law. We'll do a question because this V is equal to IR you will be able to do, but questions of graph also come, so you should be able to handle the questions of all the graphical questions. Just note down this, then we'll do a question on the graph of Ohm's law. Yes, the value of temperature and the value of the pressure is not variable. Means if it is, let's say, 237 Kelvin, so it is 237 Kelvin throughout the whole entire wire. But when you will be having situations of Ohm's law, no, that is assumed that temperature and pressure is constant. Bafia, did you get the recording on the group? I had sent it.
Yes, sir.
Till the time, note this question and try it. It is graphical question. So you get these kinds of question based on graph where angle is given. See, I versus V graph is given to you, and you have to tell the resistance of A, you have to tell the resistance of B. Angle between A and V is 30 degree. Angle between B and V means basically this is the x-axis, this is the y-axis. So this entire angle is 60 degree, this smaller angle is 30 degree. So you have to find RA and you have to find RB. Take 2 minutes, note down the question, try it yourself, then I'll help you. I'll discuss it with you. But at least try, because in the last class, I think we have discussed whenever we have slope. Yes, in the last class we did it. Whenever we have to calculate the slope is given by ratio of the two quantities. Like resistance will obviously be given by division of these two. And that is calculated with the help of tangent. That is tan theta. So slope is given by tan theta. So what will be RA? What will be RB? So, no answers. Did anyone try? I even gave you the hint of tan theta. Yes, yes. No, Fahad. See, tan theta will be okay. I'll discuss. I'll discuss. See, the graph is what? Graph that we discussed. It was I versus V or V versus I. Look at the graph that you have just drawn. Is it I versus V or V versus I graph? Just look into your notes. You must have drawn the graph just before this. This one class, this graph. V versus I, yes. This is V versus I. It means the slope of this graph. See, what do we want? We want resistance. And apply this thing not only for this question and this chapter, for your entire physics or even for students who are having maths. Apply this concept. This concept will be the same, it's just that variables will differ. Like in the last class, we had seen the graph between charge versus the time. That gave us current. So concept was the same. Here also we'll have the same concept. This is resistance. I'll check the angle. What was the angle for A? A is 30 degree. Okay, Zaid. See Zaid and others also. Even Fahad, you were asking something. So whenever you divide two quantities, because obviously if you divide V by I, you will get resistance, and that is what is required right now. Now you have drawn the graph between V versus I. It means the slope of this graph will give you R, because we have taken this in the ratio. We have this taken in the ratio division form. Whenever you take anything in the ratio and you are getting the third quantity, it means the third quantity can be obtained by the slope. This means the slope is R, that is resistance. And how do we calculate the slope? Slope is calculated with the help of tan theta. It means tan theta is what? Tan theta is V divided by I. Here what do we have? Here we have the graph between I versus V. It means I by V will give you what? 1 by R. And R was tan theta. So here it will be 1 by tan theta. Had it been V versus I, you would have directly used and the answer that you people are getting. Here you have I versus V. So it means it is 1 by R. So you have to reciprocate everything. Instead of getting tan theta, you will be here having 1 by tan theta. So RA will be what for the first part? Resistance A. This will be 1 by tan 30 degree. So tan 30 degree is what? 1 by root 3. So this becomes 1 by root 3. Root 3 will go up. That becomes root 3 ohms. Oh yes, one thing I haven't told you. The resistance symbol is ohm. This is omega. This symbol is called omega, but the pronunciation and the name of this quantity SI unit is ohm. OHM. Ohm's law, based on Ohm's law. That was the name of the scientist. So this is ohm. So this is RA. So Z, did you understand why it's not 1 by root 3? It is 1 by 1 by root 3. Here and to others also. Similarly, RB will be what? This will be 1 by tan 60 degrees. Tan 60 is root 3. So 1 by root 3 ohms. If there was V by I, there would be no 1 by tan theta. Yes, there would have been directly tan theta. Mean RA would have been 1 by root 3, RB would have come out to be root 3. Had it been V divided by I, means V on the y-axis, I on the x-axis. Just note this down as well. That completes your Ohm's law. Ohm's law is a very small portion. We have to main focus on this resistance, because Ohm's law gives you the term resistance, and then you have a whole thesis on resistance and resistivity. So note this down, then we'll do resistance and resistivity. All right, sir. Yes, yes, you have to reciprocate. Your answer was correct had it been V versus I. So be careful whenever you see the graphs. Is it the same as you are doing it, or some changes are there in the graphs? So using Ohm's law, this we have. This is using Ohm's law. Using Ohm's law, we have the value of resistance, that is the ratio of V and I. So basic easy questions you people should be able to handle. If V's value is given, I's value is given, how to calculate value of resistance. Tougher questions include the graphical questions where I versus V can come. That was the maximum part where the questions can lead to. Now the calculation of resistance. Resistance derivation is also based on Ohm's law only. So actually it's a kind of elongation of Ohm's law. Ohm's law is not stopped. We are using, or basically we are applying Ohm's law. It is one of the applications of Ohm's law. You can say it like that. Now see, I is equal to NEAVD. I'm not audible. Class, is this not audible? Others?
It is audible, ma'am.
Is audible. Fahad, just check your connection. I think others are able to hear it. Now see, this is a wire. I have taken this the same wire for which we had concluded Ohm's law. Now current is equal to INEA VD. That is the definition of current that we had derived in the last class. Okay, fine. Just check. If anywhere you people are not able to hear, just interrupt in between. And the formula of drift velocity we had seen, minus E capital E tau divided by M. So who can tell what was small e and what was capital E? Rifat, can you try what was small e in this formula, VD? This small e. What was this? This one. Rifat, just try and help you. Remember E, we had discussed in first class also, when I had a class with you. Yes, Sam, you're right. It's the electronic charge. Electronic charge, that is 1.6 into 10 to the power minus 19. Clear, Rifat? All right. And capital E is the electric field. And M is the mass of the electron, not the mass of the conductor. Means even if the mass of the wire is given, don't write it. Use mass of electron. Mass of electron, charge on electron, electric field, and the relaxation time. Clear? Now let's put in the value of drift velocity from here into this here. Let's put it. So I will be NEA, and instead of VD, I am writing E capital E tau divided by M. The negative sign. Can anyone tell what did this negative sign symbolize? Last class I had told you people, and you people have written it also. Anyone who remembers it? No one. Direction. So only Samya studies. Negative charge. No, not the negative charge there. Charge can be anything. Electron is already a negative charge. That doesn't symbolize the electronic charge. Direction. Sami is right. See, direction means will drift velocity's direction and direction of electric field both are opposite. That is meant by this negative sign. Just revise it before the class at least. So that's why assignments are provided to you. Are you people now receiving the assignments? Electrons direction, yes, ma'am. Direction of electrons and direction, all is because of direction. When you get the assignments, try to do those 3 to 4 questions. Those are questions based on the class only. So even if you're not getting time to revise before the next class occurs, the assignment will help you to revise the basic things like these full forms. What is E? What is capital E? Right now, I haven't even asked a tougher question. No Viva has been taken right now for this batch. So I is equal to, and since negative sign symbolizes the direction, I'm not using it right now. Here, this is. So E can be squared. This is N E square A tau capital E divided by M. Now, electric field is E, capital V is the potential difference. We have done it a lot of time, at least students who were there in the last lesson. What was the relation between electric field and potential? Electric field and potential. There was a relation between electric field and potential. Let me tell, okay, let's say L is the length of the conductor. L is length. Can you relate these three? Anyone? Electric field is negative space derivative, negative potential derivation, not space. What is space? Yes, Zaid is able to recall. Yes, I think Zaid, you were there in the class. Partial differentiation, we did it. Remember? I think Zaid, you were not there when we did partial differentiation. Okay, okay, you were in there. Some students were there, like Fahad, Samia, Rifat, Reem. I think you people were there. See, electric field, this formula. Remember we did this. E is equal to minus dV by dr. This formula we did. Relation between electric field and potential, where negative sign signified that electric field decreased in the direction of potential. All these are related and these are utilized. So if you ignore the magnitude, if you just ignore the sign, if you just write the magnitude, you can write E as V by L. Is this point clear? If any doubts you people are having or you're not able to recall, ask me. I'll revise it. That I'll repeat the topic or whatever doubts you have. Let's put the value of electric field. So I is Ne square A tau. Instead of electric field, I should write V by L. No, this is V by L. V by L and the mass. Now see, let's just transport V also there. This becomes I divided by V, which is what? Ne square A tau divided by M by L. Let's reciprocate it. V by I. This is what? ML divided by Ne square A tau. V by I. Reem, what is V by I? From Ohm's law, try to recall. We have just done it. Reem?
Potential and current.
Potential. This is
Yeah.
potential, this is current, right?
Yeah.
So V divided by I. What was the other quantity in Ohm's law left? V is equal to I multiplied by something. Reem, you also try? Yes, Fahad, Samia, right. One thing, just look in the Ohm's law section, or you must have written it in your notes, wherever you are writing. One quantity is there. What are we studying? The quantity that we are deriving. V is equal to I something. Are you able to recall, Reem? See. This, remember? What was this?
Resistance.
Resistance. Exactly. So yes, over there, Wafia, Samia, and Fahad. Yes, resistance. Capital R, resistance. V is equal to I, R is Ohm's law. So from there, R can be written as V divided by I. So it means this quantity is nothing. This is simply resistance. Resistance can be written as ML divided by A NE square tau. Is it clear? Reem, is it clear?
Yes, ma'am.
Now, there are few things on which resistance depend, and that is not only used for your theoretical papers, that is also used for your derivations, other derivations. Now, see, resistance is directly proportional to length, whatever is the length of the conductor. And resistance is inversely proportional to area of cross section. These 2 points are very important. Mark them as important. This will be used, and these are asked a lot. Apart from this, nature of material and temperature. These are the factors on which resistance depends on. Resistance, variation of resistance. So basically, resistance is what? Resistance is a measure of opposition of current flow in electric circuit. This we have discussed. SI unit is ohms. The symbol is called omega, which is pronounced as ohms. Yeah, so just note down everything about resistance and we'll do resistivity, and all together then we'll do numericals on this. And remember, all these things are important from your board exams. Board exams include all these derivations in all the types of board exams.
Ma'am, why minus goes when we are substituting?
Minus doesn't include because we are just considering the magnitude. Minus sign represents what? The direction of drift velocity and electric field, and that is not of your concern when you are just focusing on the current. Current means that is flowing within the wire. That's why we ignore all the negative signs, because all these negative signs do not have a significance in the numerical portion. They just have a significance within themselves. So that's why we can ignore it in the derivation. Yeah,
Yes, ma'am. Ma'am, in the numericals, they will give all the values
all
of
the
this
values
formula.
of all the values, and mostly this formula ml divided by ane squared tau, this is least utilized. Either it is given as v is equal to ir formula, where you can get the value of resistance by divided by I, so potential and current is given. Very means rarely you see this formula utilization. Otherwise you have the other formula that we'll discuss along with resistivity, that is r is equal to rho l divided by a. Only these two formula are mostly used in your exams. If it comes in the exam, they will be providing you with the length, with the number density, relaxation time, and area. Electronic charge, you already know. Mass of electron, you already know, so you can calculate. Now this quantity resistivity. What is meant by resistivity? See, resistance we have discussed. Resistance was what? That was the constant which came as a substitution of the proportionality sign within potential and current. Now, what did we discuss right now? We discussed that resistance is directly proportional to the length of the conductor. First thing we discussed was this. Second point that we discussed, which I also marked you people as important, that this is one of the important points, that resistance is inversely proportional to area. So if I combine these factors on the proportionality, this becomes what? Resistance is directly proportional to length by area. Again, you will be having a constant. So that constant here is known as resistivity. We'll define resistivity also, but understand this right now. Resistivity is the constant, and this is represented by this symbol. The symbol is called rho. Rho, I think you must have used in your 11th class also. Rho, this symbol is utilized. This symbol for surface charge density, that is sigma, and this symbol is rho. So R is equal to rho L divided by A. So as one of the students, Fahad, was also asking, this formula is frequently used. And this is not only used in your physics, in your electrochemistry type lessons, I think in chemistry, this formula is again used. So R is equal to rho L divided by A. So two formula of resistance, three formula we have seen. First one was V by I, second was ML divided by A N E square tau, and third one is rho L divided by A. So resistivity is what? Now this is the formula of resistance, but we haven't received what is meant by resistivity. We haven't concluded or reached to that. See, how will I write resistivity from here? Resistivity can be written as R into A divided by L. Now tell me one thing. If I write area as 1 meter square, and if I write length as 1 meter, what will be the relation between resistivity and resistance in this formula? It will be equal. Yes, Bhavya, it will be equal. Mean resistivity will be equal to resistance. So how can I define resistivity? Resistivity is basically, and understand this, by this you will be able to learn the definition of resistivity here and here. Resistivity is what? Resistivity is the resistance offered by unit length per unit area. For unit area and for 1 meter length, whatever is the resistance, you call it as resistivity. This is basically definition of resistivity. Here I think I must have written it. Yes. Resistivity of a material is defined as resistance of a material of unit length of unit area of cross section. So basically you can define it in terms of this. And also one more thing, resistance is, from the relation also you can see resistance and resistivity. The formula of resistance, resistivity, let's write it first. Let's write the formula of resistance. So formula of resistance, resistivity was what? R A divided by L. Now put in the value of resistance, the second formula that we had calculated while deriving it. It was ML divided by A N E square tau. Now what is left? This is resistance. This is just R. What is left? A divided by length. Can you notice L and L are getting cancelled, A and A are getting cancelled. Formula of resistivity also becomes M divided by NE square tau. Now the SI unit of resistivity. SI unit of resistivity, see, from this formula we can write. Formula of the SI unit of resistance is ohm. SI unit of area, it is meter square. SI unit of length is meter. So 1 meter, this gets cancelled. SI unit becomes ohm meter. This is ohm, this is meter. So this is all about resistivity. Now we'll be using this formula, will get used a lot. Resistance is equal to rho L divided by these formula. Both these are same actually. These will be used. So we'll do numericals on this, but first to note the points on resistivity first. Then we'll do a question. One or two, three questions we'll do simultaneously.
Ma'am, can you scroll down?
For those who have written the portion, you just note down the question as well. See, it says that length of a wire increases by 2%. Calculate percentage change in resistance and resistivity. This is the question given. You have to find out the percentage change in resistance and resistivity. See, resistance is what? Before resistance, resistivity part is easier to do. Resistivity was what? Resistivity, as you had seen in the derivation, we did it. Resistivity came out to be L and just I'll show you that we wrote. See, A got cancelled, L also got cancelled. So in this, you can conclude that resistivity, this is independent of length and area of cross section. So even if your length increases by 2% or resistance changes, there won't be effect on resistivity. So resistivity remains the same. Had it been rho only, it would be rho still. But resistance will change because resistance, we had seen resistance formula is rho L divided by A. Now, length of wire has changed. This was the initial. Let's say this is the initial resistance. Now we have to calculate the new resistance. Resistive will be the same, new length and new area of cross section. All these things we have to find, then only we'll be able to find out the percentage change. For length, see length, what happened to the length? Length increased by 2%. So new length will be L plus, it's 2%, no? So 2 by 100 original length, that's how we calculate the percentage increase. Had it been decreases, then we would have written a negative sign over here. Since it is increases, so we have used plus sign. Had it been in decreases, then only negative sign would have come. Normal percentage change calculation, the way you have been performing. So length becomes what? New length. L prime, this will become 100 L plus 2, 100 L plus 2L divided by 100. That becomes 102 L divided by 100. This becomes what? L prime. L prime becomes what? 102 L divided by 100, which is 1.02 L. So we have the value of the new length in terms of the earlier length. How 100 comes in the numerator? Here, it comes by taking LCM. LCM of this is 100, so we have to multiply the numerator and denominator of this term by 100 as well. Since 100 multiplied by 1, the LCM, normal lowest common multiple we have taken. Fine, far? So this is the length. So length we have solved. Now area, regarding the area. See, area, directly you have no information about the radius. Neither you have information about the radius, nor you have the information about directly the whole area. But one thing that will be same beside this resistivity. Can anyone name that quantity according to you? If I say this was a wire, this was a wire. I have increased its length by 2%. Now this is the wire. Initially the wire was this. Now I have increased its length by 2%. Beside resistivity, can you name any quantity that will remain constant? Area of cross section? No. See, Bafia. Let's say this is a wire. Here, this is a wire. If I extend it also, no. If I'll extend it, I'll pull it. I have increased the length. But will you notice that area will become not increases, decreases fast. It will decrease. You try yourself. Suppose you have clay with you. If you have clay with you and you increase the clay like this, if you increase it, then what happens to the area of cross section? Area decreases. So that will be the same case over here also. Let's say this was the wire and you have pulled the wire, you have increased its length. So what happened to the area of cross section? That decreases. So area of cross section definitely decreases. But why does it decrease? Which quantity remains the same? So that area of cross section has to decrease. No idea? Resistance changes. Resistance definitely changes. Length is changing, resistance area is changing, so resistance also changes. See, volume. The whole volume will be the same, no, of the wire. Like the example I was talking, giving you about the clay. If you have a piece of clay with you, if you mold it into a thick cylinder, the volume is V. The same volume of clay is there, and that cylinder, if you increase the length and decrease the diameter and make it into a very narrow cylinder, then also the volume of the clay is same, no? So that's why volume remains the same, because we are not uh, deleting or removing any matter, neither we are adding any matter to the wire. So basically whatever was the volume, that remained the same. So apart from resistivity, volume remains the same. So initial volume is equal to the final volume. Volume remains constant. Now initial volume was what? Area multiplied by the length. Final volume is final area multiplied by final length. Area L can be divided by L prime. This is A prime. L prime we have calculated. L prime we have calculated, that was I think 1.02 L. So area is what? We have the value of area as well. Area is A divided by 1.02. Now can we calculate the final resistance? Because until and unless we have the value of final resistance, we cannot calculate the percentage change. Now let's put in the values. Rho, instead of L prime we have 1.02 L. Instead of area we have A divided by 1.02. This will go in the numerator, no, since it is in the denominator. So R can be written as 1.02 whole square rho L by A. Rho L by A is the initial resistance. So R prime is what? This is 1.02 whole square. R was the initial length. Now, what will be the square of 1.02? 1.004. Just check. Square of 1.02 will be what? Will be somewhat 1.004, no? Just check it. This is what? This much times the resistance. Now see, for calculation of percentage change, percentage is calculated how? Final quantity minus initial quantity divided by the initial quantity multiplied by 100, obviously. That's how we have been calculating the percentage change. 1.0404. Okay, sir. This is 1.0404. Okay, thank you, Zed. So we have the final resistance also. Now let us write 1.0404 R minus original R divided by the original length into 100. This is the formula of percentage. From your earlier classes, you must have done this. So R you can take common. This becomes 1.0404 minus 1 divided by R into 100. R gets cancelled. 1.0401 minus 1 becomes 0.0401. So this becomes 0.40. This is 0.0404 into 100 So this becomes what? 4.04 percentage. This is the percentage change of resistance. That's how you will do it. Yeah. One short trick I'll give you. Let me tell you, but there's a very short trick to analyze your answer. That won't help in your calculation because obviously this is such a precise answer, 4.04 percentage change. Whatever is the change in length, this was 2%, no, here. Whatever is the, this is a very shortcut to just check whether your answer is going in the right direction or not. For example, had I got the question answer, like initially I was using 1.004, so my answer would have been 0.04. Then how would I check whether I was performing the calculations correct or not? If your length is, let's say, X percentage change has been occurred in your length percentage, then percentage change in resistance becomes 2x. You can see if it was 2% change, now it is coming around 4%. So even if you get your answers like 6%, 8%, 20%, 0%, something, you can analyze with it. Yeah, note down this question as well. Then we'll do 1 or 2 questions more, which come based on this question, based on this formula. Yes, these types of question come in the exam. This is a previous year question only. Square because see here, this has gone in the numerator. It was a divided by 1.02. So this 1.02 multiplied by this 1.02, that became the square. Are you people having your summer vacation still? Zed, I think it is over, no? In your school? Or is it going? Zed. It's going over. It's over. You're in which state, Zed? All right, fine. Now we'll see two types, malab, second type of question only from this only, but we'll see two categories of it. This was one type where the length changes and you see the difference in the resistance and resistivity. Remember, resistivity will be mentioned to you, and all those who will be appearing for their entrances after the 12th board, this comes definitely in the exam for resistivity, because students waste their time on performing calculations on resistivity. You will be giving resistivity's value, you'll be giving variations in length, you'll be giving variations in area that doesn't affect your resistivity. Resistivity is just material dependent property. For example, if I say a copper wire is there, if a copper wire is there, then the copper wire will be having its own resistivity. And if I change the material, for example, I change let me take a brass wire or a zinc wire. Zinc wire will be having its own value of resistivity. Brass wire will be having its own value of resistivity. So resistivity is a material property. It's like density. Density, even if you take a very small droplet of water, the density of it will be 1000 kg per meter cube. And even if you take the whole ocean of water, that density of water will be 1000 kg per meter cube. That's the case of resistivity. It's a material dependent property. So don't get confused about resistivity. Note down this portion as well. I didn't scroll it till here. See, if you get such a question, no, where a cylinder or any known shape is mentioned, like a cube, cuboid, sphere, all these known quantities are mentioned. So cylinder, you people know, area of cross section is what? Area of cross section will be pi r square. So resistance, if you are asked to calculate, it will be rho L divided by A. Instead of A, you can write pi r square. If it's a square, you can write it as length multiplied by breadth. It was a circle over here. It had a circular end. Had it be having a square end, a spherical end, then you would have used length into breadth. Similarly, for square it is a square. For rectangle it is a length into breadth. So whatever are the formula for area, you can apply it. This is another type of question. Now similar to this that I was telling you, know, that both the questions are similar. So here we have, I'll give you time to write it down. See, this is a cuboid given, and you can be given any two sections of the cuboid to calculate the resistance. The resistivity of this whole material is rho, that is fixed. Now look at end one. This is end one. Are you able to see? This is end one and this is end two. For the first part, resistance is what? Resistance is rho L divided by A. This is fixed. So for the first part, the resistance will be what? Rho is there. This is, see, rho will be the same. Now, we are having what? This is the height, this is the length, and this is the breadth. What is the length between these two, 1 and 2? They are separated by how much distance? This is 1, this is 2. Both of these are separated by how much? L. Yes, there. They are separated by L. So it will be rho L divided by A. Area of the cross section means through which the current will be flowing. Means this part. That is breadth multiplied by the height. So here it will be BH. This one. If we talk about the second part, R is equal to rho will be the same. Rho will be the same over here for the second part. Now, Abia, can you try this for this third and fourth part? This upper part is the third one. This bottommost part is the fourth one. Well, how much they are separated by which distance? Abia, can you try?
They are separated.
They are separated. See, this is uppermost is 3 and bottommost is 4. See their separation. This separation between both of them. See, it's given. It's written. Just you're not just able to see. Something is given. Upper,
Length.
not length. Length is this.
Sorry, we have to take the height of it.
Height. Yes, this separation. So yes, that height was right. Like in all questions, rho will be the same. Rho will be the same. This is RHO. Rho. Rho will be the same because it's resistivity. The material is same. Areas differ. So here the resistance will differ. Resistivity will be same. So H, yes, as rightly said by Abia, this is what H. Now area becomes area of each. This is length, this is breadth. What will be the area of this rectangle? Length into breadth. So this is your value of resistance. Now see the last part, 5 and 6. Since it's a 3D figure, it's difficult to draw on 2D. You can just imagine the front face of the cube and the back face of the cube. This is 5, this is 6. A front face is 5, back most is the 6th. So by how much distance they are separated? Breadth. Bafia is right. Not L. L is this separation. This separation. this, front and back. B, Bafia. Your answer is right. This is B, the separation between them. See, this is the separation. This is the final wall. This is the initial wall. This is the separation between them. So R will be equal to rho. Instead of L, we'll be having B. And area of this rectangular face is what? Length multiplied by height. Yeah, note down this expression. Text me done once you have completed. Area C. Area is defined by whichever section you are considering though. Let's take this 3. For example, let's take 3. So where is 3? 3 is this. So this is what? This must be the breadth. And this is what? This must be the length. So that's why length into breadth. This is the whichever section you're taking. Let's say sixth. So sixth one is this. Let me show you sixth one. Sixth one is this one. This face. This one is the sixth one. This face. This is sixth one. This one. So what will be the sixth one? This is the length. And see, this is the height. So length multiplied by breadth is given as the area of rectangle. So here the length is L and breadth is height. So that's why LH is there instead of 6. Numericals on what? Numericals on this. This is a numerical only. This is a type of you don't get values in this. You get in terms of BH only. These kinds of question only you get. Numerical you get that we had done already. This one. These kinds of numericals. Or otherwise directly R is equal to rho L by. Usually it comes to just put in the values of LB, LBH. You should know how to write all these things. Written others. Have you people completed the writing part? Zaid, Fahad, and others completed. And what about Rifat and Abia? You both have also done? Okay, if you people have any doubts, you can stay right now. Otherwise, your time is up. I'm stopping here. A very, very small portion, that is how the temperature affects the resistance is left. That we'll do in the next class only because it's a huge topic. And then we have terminal potential EMF for this. And if you people have your assignments, do submit it by the end of the week. Fine, so I'm stopping here. All right. No, take care. Bye-bye. Okay, Allah Hafiz.